Hello dear students. So today we will talk about the slope of VI graph, that what we get through the slope. Now what is the slope? Slope is generally the inclination of a line towards the base. So here we are talking about this angle. Suppose this angle is theta. So in this case we are going to calculate that what we will get through the slope of VI graph. Okay. So here we are having a straight line. Straight line means a particular resistance following the Ohm's law. So here we will calculate the slope between the 2 points. Suppose I am having 2 points. Here is point A and second point is here, that is B. I will calculate slope here. So I will draw the line one by one. Suppose I am drawing the projection from A point to here, and one and second projection I have drawn here on the V side, and a projection I have taken from B also from this side, and from B point I have taken the projection from on the V side. So what these projections are telling? It is telling us that at a particular value of V, it is having the current I1, and at point B, it is having the current I2. For I1, the potential here will be the V1, and for I2, the potential here will be the V2. Okay, so we are going to calculate slope here. Suppose I am drawing this particular line here. So we are going to calculate this angle, that what we will get through this particular value. For calculating this value, we know the trigonometry also, that in a triangle, if it is an angle theta, for this angle theta, if we are going to calculate the slope, the slope will be equals to perpendicular upon base. So we need to calculate here perpendicular and base also. Here what is perpendicular? Perpendicular is this particular line, and base is this particular line. Suppose I am giving the name to this triangle, it is triangle ABC. So first I will calculate this value, that is what is the value of BC here. BC will be equals to V2 minus V1, and AC will be equals to here I2 minus I1, because we are calculating this particular length. How we can calculate it? First we need to understand this I2 and this I1 here. When we will subtract I2 minus I1, we will get this particular length. Similarly, here it is V2 up to this point, and here it is V1. When we will subtract V2 minus V1, we will get the required value of this particular length, and it is parallel to this particular side. So the BC will be here V2 minus V1, and AC will be I2 minus I1. So we can calculate here slope. We know that slope will be equals to perpendicular upon base. Here perpendicular is V2 minus V1 and base is I2 minus I1. We can understand here that when we will subtract V2 minus V1, we will again get the potential, and when we will subtract I2 minus I1, we will again get the current here. So V2 minus V1 will be del V, and I2 minus I1 will be del I. Okay, here del is showing us the change, so slope will be equals to like this. Okay, and in the next part we know that by Ohm's law, we know that V equals to IR. R will be equals to V upon I. It is suppose equation 1, it is equation 2. If we compare both the equations, so we will get that slope of a VI graph will tell us about the resistance R of the conductor. Resistance R of the conductor, because this particular side is equals to this side, it means slope will be equals to resistance R. So in the VI graph, from the slope of a VI graph will always tell us about the resistance R. Okay, so we can say that by the slope of the VI graph we can calculate the resistance R. For calculating the resistance, we need to find out the value of different points. Suppose here the point B is here, we need to calculate here V2 and I2, and at particular point A we need to calculate here V1 and I1, and by putting the formula, that resistance R will be equals to V2 minus V1 upon I2 minus I1. We can calculate the required resistance of the conductor. It is the required formula.